Welcome to everybody that's starting to join. We're going to get started here in about 3 or 4 minutes. So come on in and get settled, and then we'll start, like I said, 3 or 4 minutes pretty promptly. So thank you, everyone. Welcome to everybody that's joining. We're going to get started here in just about another 30 seconds, maybe a minute. So come on in and we'll get going here quite shortly. All right, welcome to everybody that's joined. We're going to get started here now. Let me disable the great music we had going. So let's go ahead and get started here. So I'm going to turn on my video for a moment so I can say hi. There we go. Wow, glare and bad hair day going on. But welcome everybody to today's session. My name is Josh Braltheim. I'm going to be leading today's session. I have a couple helpers here as well that I'll introduce in a moment. But hopefully you're here for our Sumo Logic Cloud Security Monitoring Analytics certification class. If you're not, I'd encourage you to hang out with us for the next 3 hours anyhow, but that's what we're going to be doing. So as I mentioned, I'm going to be leading today's class, and my name is Josh Brault. I'm lead trainer at Sumo, but I have two of my helpers with me today. So I have John Meredith and Odell Gordon out there. And so they're going to be helping answer questions on the chat side of things. So as we're going through today's class, if there's any questions, concerns, thoughts, feedback, what have you, go ahead and put that into the chat. And we're also going to use the Q&A portion as well. So depending on if it's a question or just the general chat, you can use either one. And so we're going to go ahead and jump in today. And today's going to be somewhat interactive. So we're going to be doing some labs. And so you may need Odell and John to help. And if you do, they're out there for you. So let's go ahead and dive in here and get going. I'm going to turn off my video. It was being a little flaky earlier. So I want to make sure my presentation is clear for all of you. But here's our agenda for today. So as mentioned, we're going to be together for the next 3 hours. And so here's the schedule. The first 10 minutes or so are going to be introduction. And as we're doing, we're introducing ourselves and the organization. We're going to do a security demo for you. So I'm going to go ahead and to show you a couple different screens of how security can help. And then we're going to mimic or recreate some of those screens later today. And then we're going to do some labs. And that's really going to be the chunk of today is labs. So we're going to do, as it says here, about 8 different labs. And so this is going to allow us to get interactive with the data and start to go ahead and play and figure out how some of these queries that we're going to look at in the demo can be helpful. And so that's the plan. Then the last portion of today is going to be the certification. And so what we're going to be doing there is we're going to go ahead and take a certification exam. Hopefully you've taken one with us before. And if you haven't, that's perfectly fine. But we're going to go ahead and do that together shortly as well. And so that will be the last hour. So let me go ahead here. Let me one moment. There we go. And before we actually get into the demo, let me go through a couple slides here. We don't go very slide heavy in this class, which is usually a good thing. And so I just have a couple to kind of set the table. Now, one slide that I think many of you are going to be interested in is the promotion we're running. So we want to thank you for joining today's session. We want to encourage you to get your certification on today's topic, and we want to reward you for doing so. Typically, when we would do these classes back in the old days, we would do these in person and we'd feed you. And everybody loves food. Well, unfortunately, we can't do these in person right now, but we still want to feed you. And so here's how you can get fed. Basically, as I mentioned, take the exam at the end of today's class, send it to training-promotions@sumologic.com. And I'll remind you of that email address later, but basically you'll send it to us. And then within 48 hours or so, maybe 72, depending on when you send it in, but pretty quickly after, we're going to send you a Uber Eats voucher. And so that's going to be good for $15, which should be enough to allow you to get a meal. So certainly want you all to take advantage of that. I'll also remind you of that promotion later. So that's going to be probably a big note there that everyone wants to pay attention to that one. So I certainly want to remind you of that. All right, so now that you're going to be fed, now we can get into some content here. And what I want to do first is I just want to talk a little bit about Sumo Logic itself as a company. You may be familiar with us, you may not be. This is not intended to be a sales pitch by any means, but just want to kind of level set of who we are, how we fit into your world, I guess, to some degree. And so what we're talking about today is Sumo Logic's continuous intelligence platform. And what we're showing here at the top of the screen are essentially 4 different dashboards or 4 different views in ways that you can have your data come through Sumo Logic, analyze it, run queries on it, and present it back to you in meaningful, valuable information. That information can be in the form of operational intelligence and understanding what's going on and what people are doing. Security intelligence, and that's really where our focus is going to be today, in how can you use Sumo to detect what are users doing? What are they accessing? Are they accessing things as root? Should they be accessing things as root? And so on. Business intelligence, looking at how various aspects of your company are running, and then global intelligence from a worldwide perspective. So security intelligence is really the point of today. But important to remember that we can help you with all of them. And then How does Sumo Logic work? Well, it relies on your data. Your data is going to be varied, or it may not be, but typically it is. And so you might have data all around the world in very different formats and systems, data that's being generated by apps and microservices and SaaS and third-party systems, et cetera. And so all that data needs to come into Sumo Logic so that we in the system can help you with it. Once the data is in Sumo Logic, then you can rely on our analytics, the multi-tenancy, the scalable elasticity, which is really going to be helpful to allow your systems to grow and shrink as appropriate. Machine learning, APIs, great ways to have the system do some of the work for you. Advanced analytics, and we're going to look at some of those analytics today, and then security and monitoring, which we're really going to look at today. On the far right, we have some of our attestations and certifications, the HIPAA, the FedRAMP, PCI, a little probably US centric, but we have the corresponding ones globally as well. And so important to remind you that we are security minded as well. And then finally, who can benefit from Sumo Logic? Well, anybody can. And so regardless of if it's your DevOps people, your engineering folk, customer success, they can all utilize Sumo Logic and then benefit from it. And so just want to kind of remind you of that. All right. Let me go, actually do 2 more slides and I'll do our little demo. So on this slide, talking about the security intelligence. But now I want to go a little bit deeper when we refer to security intelligence. What are we talking about? And really there's kind of 3 prongs to it, if you will. Well, if a prong reference is appropriate. But so there's the security side of auditing and compliance. And as it shows here on the left-hand side of the screen, we can help you with that using our secure platform. You can look at data collection and ingestion, utilize some of our compliance apps that can help you get a better understanding of your compliance needs and if you're meeting them. Security analytics, and this is really what we're going to be focusing on today, is using queries and searches, using the dashboards and the alerts and those advanced analytics to see what's going on into your system and deciding is that malicious or not. And we'll go through, like I said, many examples shortly. And then Cloud SIM. This is our security called an add-on package, I guess. Cloud SIM. We're actually going to be talking about this tomorrow evening, or depending on what time zone, but tomorrow and the next day as well. So hopefully you're joining for the next 3 days because we're going to be doing a lot of security. And so Cloud SIM is our Cloud SIM security product that allows for threat correlation, as it shows here, workflow with event management, and some automated incidents. So prioritization. So taking these threats that might occur and having the system do things with them and reenact playbooks and things like that. But as mentioned, we're really focusing on this middle portion today, security analytics. And then within security analytics, once again, we'll be looking at searches, dashboard, and then some of the advanced analytics and kind of a big combination of all of them. So let me go ahead and show my little demo here. And what I wanted to show here is a screen that I've created or a dashboard with panels that or somebody in my organization has created. We can leave it kind of generic because I can create these things. Other people can create these things. We can share and collaborate together, which is always good. But here's an example of one that I created, let's say. So what am I seeing here? It's called Security View. Hopefully it's showing me some security stuff. And so let's start to see what that stuff is. So on the first panel here, we have SSO and non-SSO login locations. So what this is showing me is from a global level, where users are logging in, or where machines are logging in, or where API services are logging in, but where logins are taking place. And what it should, if it redraws properly, try it again. I don't know, but what we're seeing here is a map of the world. And so what I'm seeing here is dynamically over the last 60 minutes, this is where users are coming in. And so I see users coming in from Asia and Japan and all over the world. Now, from a security standpoint, this can be quite valuable information because this is showing me where my users are coming in. Let's see, what is it doing that? There we go. Sorry about that. And so, like I said, we see this worldwide map of where people, computers, systems, whatever might be, are logging in. Now, why is that important from a security standpoint? And it may not be, but Probably is. Let's say we're a US-centric company, not Sumo Logic, but our fictitious company of Acme.com. And Acme.com is based in the US, and we only really do US business. We're a small little US company. Now, if I see all these login attempts taking place, this might be curious to me. We're not dealing outside the US, yet I have people or systems all around the world accessing our systems. That might be quite concerning. On the flip side, if I'm a global company, this might be just normal business. Now, I might be a global company, but I might be a little concerned that there's users coming out of China and Russia and other areas that are in the news recently. And so this might be concerning. Now, if somebody in my organization is testing firewalls in those locations or is on vacation in those locations, which I guess it still could show up as their IP, a local IP, then that might make perfect sense. If nobody's over there and we shouldn't be doing anything with China or Russia, then that might become suspicious. And then we can take actions on that. And so this map, everyone loves a map. It's pretty simple to understand and is quite dynamic. Also scalable. So as we see here, we can really get down to where people are logging in from. And this can also be helpful for other parts of the business, but certainly from a security standpoint, knowing where people are logging in is in some cases quite important and quite telling. All right. Next one is this threat intel. What's showing here is over the last 60 minutes, the system is looking at IP addresses and has found 119 IP addresses that it has considered to have a high malicious confidence, that it's fairly certain are bad IPs or scary IPs, I guess we could say. Now, that's good to know. I probably want to know what IPs are accessing my system or intermingled with my system, and ones specifically that are deemed bad or specifically high malicious confidence. But who's determining that high level? Well, in this case, we're using I guess we'll call it a sister company or really another organization called CrowdStrike. CrowdStrike, they are experts in threat detection. That's what their organization does. We're experts in log and analytics. They're experts in threat detection. And so what we're doing here is utilizing their data, and we allow you to use their data. We'll talk about that as a lab use case probably about an hour or so. But what's occurring here is basically the system is looking at all the IP addresses that are part of your data and saying CrowdStrike thinks these are highly malicious. Now, what do you do with that? Well, that's totally up to you. Maybe you block them, maybe you follow them, maybe you give them more access and see what they do, or many different approaches, of course, to what to do with bad actors. And once again, this is CrowdStrike thinking these are bad actors or determining that they are. It's up to you to decide that they are, or up to you to utilize that information and make decisions. Another chart here is suspicious login distances. What we're doing here, what the system is doing here, is looking at a user, looking at where that user logged in from over the last 24 hours, and letting us know if this is curious or not. So what we see here is Damon here. During the last 24 hours, he's logged in from the United States, and in that same 24-hour period, he's logged in from Egypt. Now, it's certainly possible Damon did some work in the United States, got on a plane, flew over to Cairo, and logged in to do some more work during a 24-hour period, and makes perfect sense of why that behavior is being shown. Could be another case where Damon is using a VPN. Maybe he lives in Cairo, Egypt, and he's VPNing into the US for another reason, and that could be why it shows up that way. Could also be the case, and you go to Damon's manager and you say, hey, I see this weird activity by Damon. Is Damon doing either is he in Egypt or is he doing any testing with Egypt? And if the manager says, well, no, Damon's on vacation and he's on a retreat in Finland and he doesn't have access to his computer, then this becomes quite curious behavior. If the manager says, no, Damon hasn't worked here in 2 months, this is quite curious behavior. If the manager says, yeah, Damon is VPN testing from our different locations around the world, then this makes perfect sense. And so once again, this is where the data can show you what's going on, we can spotlight certain things, and then you need to decide, kind of what to do with these actions. All right, a few more here, and then we'll get into the fun of the work. Let's see, what should we look at next? Let's look at the outlier. Outlier is always important. What we're looking at here is firewall traffic over the last 60 minutes. And what we're seeing here is the system seeing how much traffic is going through the firewall and determining what is normal and what isn't. So what I see here, and I'm trying to kind of get my mouse in the way while also kind of trying intentionally to keep it in the way. But what we see here is this gray line. I guess we'd call it gray. And then we see this brown cloud around it, upper and lower limits. So what the system is doing is looking at the firewall traffic that's taking place in its history and starting to determine what is normal and what isn't. And so the system is saying, okay, I'm seeing a normal amount of traffic, normal. And then what I see here at 326 or so is this pink triangle and a spike, representing at this point there is more firewall traffic than is expected. Now, once again, why is there more firewall traffic expected? Is there a DDoS attack taking place? Maybe. Is it Bob in accounting downloading some torrent that he shouldn't, that's 60 gigs? Maybe. But that's where the system can start to tell you these things are abnormal, out of place, and then you can start to perform actions on them. All right. Yeah, that's good enough. Let's go ahead and let me go back to the deck. Oh, where did my deck go? Oh, here it is. And let's go ahead and log in together. So what we're going to do now is we're going to log into our training environment. So I'm going to go ahead and put these credentials in the chat. I think John might beat me to it, so I guess I'll race him. Yeah, he beat me. And so we're going to go ahead and use these credentials. If you haven't used these credentials before, I'll explain the formatting for them. If you have used similar credentials with us before, then go ahead and start logging in. The website we're going to go to is service.sumologic.com, which hopefully you're familiar with. If not, this is a good introduction to Sumo. The email address we're going to use. So we want to use training accounts today. We don't want you utilizing your own environment because we're going to use some test data that you might not have. So the accounts we want to use are going to be in the naming convention as seen on the screen of training plus analyst, number. And I want you to select a 3-digit number, 123 456 381 724. Pick a 3-digit number. And it's going to be at sumologic.com. So training plus analyst, number at sumologic.com. The password we're going to use is going to be new year 22 exclamation point. So capital NEW, capital YEAR 22 exclamation point. So go ahead and log in. Once you get logged in, if you can go ahead and let me know the number you're using. It's okay if we have duplicate numbers. We have a pretty small group, and it just really doesn't matter for today's labs if we are duplicating, but it's good confirmation to know you're in. If you need help, of course, with those credentials, let John or Odell know in the chat and they'll help you. Be perfectly honest, it's probably going to be a typo, but that's okay. It happens to all of us. Other thing about these credentials, and I'm going to log in myself. So let me go ahead and let me do so. Is these credentials are available to you past today. So these credentials give you access to our training environment. We're going to be looking at specifically cloud security kind of content today, but there's a lot of different content in the training environment. And so you're welcome to utilize it. And so these credentials will be available for the next week or so, and then, or I guess 2 weeks, and then they reset the first Monday of each month. I'll show you where you can look at those new credentials. But as a reminder, when we're going in here, keep in mind this is a training environment. It is essentially, for today's purposes, a shared environment. So don't put anything proprietary, nothing that you wouldn't want your manager to see or be observant of you doing. So let me just log in here. All right, I think we got a good group of people in. I don't see anybody screaming for help. If you do, please scream for help. Also, conversely, if you're not screaming for help, if you don't want to play in our reindeer games and you want to go ahead and just kind of sit back and watch for today, you're certainly welcome to. I'm gonna go through each lab, on the screen. So if you can't play or don't want to, you'll still be able to benefit. So when you log in, you should be on a screen that looks fairly identical to what I have on my screen. You may have some buttons or tabs at the top of the screen. You can close those. That's just the case if somebody else is logged into this account. And so you may see some other things that belong to other people. Just really ignore them. It's not going to impact you. The center of the screen is where we're going to be utilizing Sumo to kind of jump off from. So kind of our home page. And then we're going to use, we're not really going to use too much, but the left black nav bar a little bit. So very quick overview of Sumo. Now let's go ahead and get into the labs. Let me go ahead and just send you a link, which is this one. So what I'm pasting into the chat, and I should have done this a few moments ago, is a link to the labs. So go ahead and click on those. They should take you to labs that look very similar to what I see on my screen. And yeah, so I'll go ahead and give everybody a moment. When you get into the labs, it should take you to the front lab, kind of the introduction page, or it's not actually the introduction, it's more of a welcome. Let me zoom in. Yeah, I can zoom in actually. Thank you for reminding me. Cool. All right, so hopefully you now have Sumo open. Hopefully you now have the labs open. And away we go. So yeah, let's do it. So we're going to go to lab 1. And once again, if you need help, please let's put John and Odell to work. So it's perfectly fine if you do. And if not, that's okay too. So lab 1, what we're going to do in lab 1 is we're going to monitor user activity. Why do we want to monitor user activity? Well, we may be fairly obvious of why we want to, but maybe it's not. But we want to explain. So we want to monitor user activity to help us understand what users are doing. For today's example, or most of the examples, at least this one is going to be based off of AWS data. So we're going to actually be creating a query that's going to show us the top 10 AWS activities with user information. So it's starting to take the system, take the data in the system and start to format it and manipulate it to give us things that are helpful, I guess. Yeah, that's a good way to explain it. So as it says here, we're going to go ahead and look for the data. We're going to also learn some basic parsing, and we're going to learn how to make a visual chart. And what we're going to do is we're going to actually use a variety of panels today, or create a variety of panels and put them together to create a dashboard like I showed earlier in that security demo. So by the end of today, you're going to leave today's class with a dashboard of 6 panels, I believe. And you could take that data and import it into, take those queries and import them into your own system and start to get valuable information. And that's actually lab 7. So we'll go through those steps shortly. So lab 1, let's go ahead and start. So lab 1, we're going to look at CloudTrail data, and that's going to be our AWS source of data. What we're going to be doing for today is taking these queries or these portions of these queries and pasting them into the system and running them and seeing how they act. So we're not going to be creating queries from scratch, but we are going to be utilizing queries that are good or helpful. So I'm going to go ahead and grab this first query. I'm actually going to grab all 4 lines. So I'm going to go ahead and grab them. I'm going to copy them. I'm going to go into Sumo Logic, and I'm going to go to a new log search. I can go to a new log search by either going to this log search button or going to plus new and going to log search. And I encourage you to use the plus new, that blue button, because we'll be doing that a lot. Let me see, am I zooming? There we go. And so what I'm going to do is paste this query in. Now, before I run it, and if you want to go ahead and run it, you can. It's no harm in running it yet. But what I'm going to do is I'm going to turn off these last 3 lines. By putting in 2 backslashes, I'm commenting on those lines or commenting off those lines. Basically, it's telling the system, it's as if these last 3 lines do not exist when I put these 3 dashes. And so what I want to do is I want to go ahead and start to, I want to go ahead and run the query because I'm going to run just the first line, show you what it's doing, run the second line, show you what it's doing, and so on and so forth. Now, we're not going to do that every time, but for the first few queries, we will, because I want to start to ease you into the data. So I'm going to go ahead and click Start here. And so what I'm doing is I'm just running the first line. Now, by running this first line, what I'm doing is saying or telling the system, get me my CloudTrail data from the last 15 minutes. And what I see down below is my CloudTrail data. There's been about 2,500 messages or 2,500 log messages over the last 15 minutes of CloudTrail data. And here's my data down below. Now, what I want to do next is I want to parse out my data. Now, what does parsing mean? What I want to do here is, actually, I'll just do it in here. Here I have my data. I have my log messages. And within each log message, I have valuable information. For example, in this first log message, I have a source IP address. This is AWS data. So I have an AWS region. Might be US West, might be US East, APAC, could be wherever. I have, what else do I have in here? I have a lot of other stuff. The other thing I have in here that's going to be helpful is my event type. Event type representing what event was occurring in AWS or via CloudTrail. So I have this stuff. Now, what I want to do is I want to utilize this stuff in my queries. I want to start to do a query of looking at different source IP addresses. I might want to do a query of looking at the different AWS regions. And so what I'm doing here in my query in these next couple lines is identifying these fields and giving them names. So for example, the second line here of user identity.username. If I go to user identity and I go to, where is it? It's somewhere in here. Here, username. I get a username. Now, what I'm going to do is I'm going to call that username or give that username the name of actor. I could call it user. I could call it whatever I want. I want to call it actor. Now, when I click the second, click search again, I'm going to have a new field called actor. And I'm going to have these actors. Kevin did this. Siraj did that. Kevin did this. Jay Schmo did that, and so on and so forth. Now I'm going to do the same thing for these next 3 lines, because now I want to run the query as intended in lab 1. When I do, I have 3 fields. In a second, there we go. It's actually more than 3, but let's go over each one. So I have a time field. When did this event occur? I have the actor. Who did the event? I have the event type. What did they do? And I have the source IP address. Where did they do it from? So already I'm starting to get information about the actions that people are taking. Now, is Jay Schmo allowed to do AWS API calls? Well, we're not really quite there yet. But certainly if he's not, then then this is quite glaring. But we're still getting to where the data is going to be easier to absorb. Let's go back to lab 1. Now, what we can also do here is we can utilize the UI to create parsing. So what we can do is we can go to our log message, any log message, doesn't matter. We can go down to the event name. And we could go ahead and type it in this format. But what we can also do is we can go ahead and highlight the event name. Parse the selected key, so right click on that highlighted portion. And then we can call this as event name, or we can any format we want. In this lab, we tell you to use lowercase and underscore. So what we're doing here is we're taking the system identification name of event name in this format and displaying it differently because we want to, or because this is a company standard, or whatever reason. We don't need a reason, but we can go ahead and do that quite easily. Now, if I run this, I should have another field called event name. And then I should have that event name. All right. And ultimately, as it says here, you should have all 4 of these lines of code. 5 lines, excuse me. Now, the next line we're going to add is kind of weird, but we have a reason for why it's being weird. So let me go ahead and grab the line. It's this where line that's in step 5. What this line says is where event underscore type matches event underscore type. Well, those two fields are exactly the same. Why am I putting a line that's exactly the same? It seems repetitive. And it does seem repetitive, but there's a reason for it. What we're going to do here in these next steps is we're going to introduce the idea of parameters. And we're going to give you the ability to create these parameters and allow your users or yourself to interact with these parameters. And rather than define, or what the parameters give you the ability to do is specify an event type that you want to look at. And so this is going to be helpful to allow us to go ahead and start to create filters, essentially. We call them parameters, but it's really what they are, filters. So let's go through these steps. That description might have been a little weird. So let's go ahead and go through the steps to really see what's taking place here. So what we're going to do is on this last line of where event underscore type matches event underscore type, we're going to go ahead and highlight the last event type. And when we do, a new dialog should appear that says create a parameter. And when it does, we want to click on that. So I'm going to go ahead and highlight. And if you notice right here, there's no text on the bottom right there. But when I do, now I have this create a parameter option. So I'm going to click on it. When I do, you'll notice, or maybe not, but here is the parameter window that pops up. And so what we're going to do is we're going to just modify just one or two of the values here. The main thing we're going to enter or modify is the parameter name. So we're just going to modify the parameter name to be event underscore type. Now we're going to go ahead and click save. And as the system points out, you should notice the curly brackets around event type. What you should also notice is the fact that we now have a parameter or a filter here called event type. And as you might be able to guess or not, but what we should be able to then do is start to search on these different event types. Now we're going to have this event type created more dynamically in a little bit, but we're kind of getting to that. So let me go ahead and just put it back to the way it was. All right, so back to the lab. We are now right about here on step 8. We just completed that. Now what we want to do here is we want to go ahead and add more lines. And so these lines are step 9. So what I'm going to do is I'm going to copy these lines and I'm going to talk through them like I've been doing. And hopefully that's a good format for you. So I'm going to do a shift enter to do a new line. I'm going to do a paste. And then I'm going to go ahead and turn off these lines and go through them one by one as I was doing. So let's go ahead. Okay, cool. So the next line we're going to do, there we go, is where actor matches actor for the same reason. When we do that, it now allows us to go ahead and input an actor or a user. Now we do need to make sure there's something in those fields because those fields or filters are working now, whether or not we want them to or not, but they are working. So we want to make sure that there's a wildcard in there so that it does pull back all the results, all the actors, all event types. We're not filtering yet. We could, but we don't want to. Now what we want to do in this next line though, is we want to count our data. We want to aggregate our data. Right now I have a list of a bunch of people that did a bunch of stuff from a bunch of IPs, but I want to aggregate that. I want to add it up. How many people did things? How many things did Ankit do? Well, that's what this line is doing. When I click start or on the search icon, I'm going to get a new tab. And this new tab is going to be called aggregates. And what the aggregates tab is showing us the summation of math, or the summation of any, I guess math. So in the messages tab, we have our raw messages. And our aggregates, we have our messages calculated or totaled. So in this case, we have our messages counted. So here we can now start to see that Mike did one create replication group. Goja did 14 attached group policies, and so on and so forth. Now, this list is good, but this list is long. This list is 25 items, and there's 5 pages, so about 100 different things have taken place. What we can do here is we can start to count these. And that's what we're doing in this next line with the top 10. What we're saying is don't show us the top or all the records, show us the top 10. What do we want to see the top 10 of? Top 10 actors, the top 10 users by event type with the count. And so when I run this, what I should now get is a list of 10 users, the top 10 users, and what they did. Now, another thing I can do here is use transposing or transposition to format this data. This view might be quite suitable to view and understand our data, but I want to show a different view, which is called, like I said, transposing. And this gives the data a Excel look and feel, where we now kind of have rows and columns. And so now I think I see a little bit more clearly what Ankit has done over the last 15 minutes, what Kevin's done, what Mike have done, et cetera. And then, should they be doing these things? Well, that's for us to decide, but now we're starting to get that tangible evidence of what they've done or what those logins have done. All right, let's see, let me go back to the lab. Let's see, so we did this step. Okay, so hopefully we are to the point together of creating this tabular table view. I think we're pretty good on questions, so I'm gonna keep going. Now, the next thing we're gonna do is creating a chart of this data. This view might be fine, but maybe we prefer charts and graphs to understand our data. Some of us do, some of us don't. It's really kind of personal preference. But in this case, we're going to insist that you do. So what we're going to do is utilize the bar graph icon. As I mentioned, by default, we're in this tabular or table view, but we can very easily look at other views. Here's a bar chart, line chart, column chart, line chart, pie chart, or really donut chart, etc. In this case, we're going to encourage you to use the bar chart. Feel free to use a different one. You can go crazy, but we want to show you, how easy it is to utilize that formatting. Now, within that formatting, you can modify look and feel, which for some users is quite important. So what we want to show here is, for example, we can go to the settings icon, and we can choose a few different things. Choose properties. We can make this red. Maybe that's more meaningful color scheme. We can move things around. Once again, look and feel, which for some users is quite important. So now I have my data manipulated and helpful. Now, the next thing we want to do, and this lab is a big lab. I forgot how large this one is, lots of pieces to it. So I'm going to kind of pause again just for a moment. But assuming we're all together with our chart, what we want to do now is we want to utilize, as I said here, a lookup table. Now, as mentioned, we created these parameters earlier, and these parameters allow me to utilize the searching. So for example, if I want to search just on Mike, type Mike. And now I see Mike's data. Cool. Now that's great. And in a short list of 3 or 4 or 10 users, that's quite easy to pick out specific people. But what if I have thousands of users or tens of thousands of users logging into my system, and I want to have the system tell me, I want to use a lookup table to see what user names exist in the data? Well, that's what we're doing here. What we're going to do is we're going to have you point to a lookup table. Now, a little bit later, we're going to actually create our own lookup tables, but we're not doing that yet. So what we're going to do here is really follow the instructions, but we're going to go ahead and so let's do these together. So we're going to go into the system. We're going to go to event type, and we're going to click on the 3 dots. When we click on the 3 dots, we're going to select manage parameter settings. Now, we're going to kind of just really mimic what we see down below. So the first field needs to be event type, which it is. Second needs to be just a wildcard. Third needs to be a string. What we want to do though is we want to go into this portion where it says set values for parameter. And we want to choose lookup. So once again, set values for parameter, select lookup, and then the lookup file we want to utilize is right here. And make sure you don't get that that period. I should remove that. So what we're telling the system is this location, somebody in our organization has created a bunch of different event types that we can select from, and we want to utilize that list. And so the last thing I need to do is just for this this field right here, I need to type event_type. So this location right here, actually you don't even need to type it, it should import it automatically. Once I have that, looking something like this, I should be able to click save. When I click save, it will save. And what I should be able to do now is if I go up to my event type, I should have a pull down. I should have a pull down, right? Oh yeah, that's and for effects to take place from start. Now, once I click start, now if I go to event type and remove the wildcard, there we go. Cool. Now I see the values that are being imported or accessed from that lookup table. All right, cool. One more step to this lab. This lab's a long one. What we're going to do now is we're going to take this panel and we're going to create a SOC dashboard. So as I mentioned earlier, and we saw in the demo, we had that dashboard. And so now we're going to create one. So what we're going to do is, once again, follow the steps. We're going to go to our dashboard and click add to dashboard. And at this point, this graph here is not technically, it's the dashboard. It's still a panel. It's subtle wordplay, but we're going to click add to dashboard. We're going to give the panel a name. So we encourage you to use the name of, as it says here, sorry, the panel name will be top 10 user activity. And then the dashboard, if we had an existing one, we would utilize that, but we don't yet because we're just starting. And so what we want to do is we want to use this naming convention of us, as it says here, SOC. What's it doing? Oh, there we go. SOC underscore JB, and then I'll use the numbers that I've been using. And the other thing we want to do here is we want to choose to create this in the old UI. So we want to turn off this item. If you do not, you will get an error. And that's what I think Jarvis is experiencing. So when you go to add this panel, you want to not create it in the new UI. I guess I'll talk about those reasons in a moment. So let me go ahead and finish this, and then I'll show it again. Actually, let me cancel. Let me cancel. So once again, I'm going to go to add to dashboard. I'm going to give the panel a name. I'm going to give the dashboard a name. And if you've already created this and you want to redo it, make sure you give the dashboard a new name and just add an additional letter or a number. And that's fine. There's no problem with that. And so I'm going to do JB 234. I'm going to click create new dashboard. And then I'm going to want to turn off this option. So I want to actually not have it in blue. Then I'm going to click add. And fingers crossed, what I should get is exactly what I got here. So I have my dashboard and I have my first panel here. So once again, just to so add to dashboard. Yeah, I think I showed it a few times, but one last time just to. And the reason, actually, there we go. I'll go ahead and do it. another one just to do it. Then I want to turn this off. There's an issue with the new dashboards and the parameters that we used. The code needs to be rewritten a little bit, and I should have done it prior to this class probably, but that's why. We certainly could rewrite them for the new dashboards, but we haven't yet. So, all right. Let's see. Let's go back to our lab. I just want to make sure we got through it. Actually, so there is another step in this lab, is the fact of the filtering. So what you may see here is when you click on the filters, now we have these filters that we can start to utilize. And so in this case, we can go ahead and look for the AWS calls, or if we put a wildcard, we can search for everything. We do need to have something in there. So if you have nothing in there, it will just do nothing because it doesn't have any parameters. So having a star is required. All right. Okay, so I think that's it. Like I said, it's quite a lab. The other ones are less comprehensive, but it's an important one. I have a couple questions here, a little quiz question, so I'll go through these. So the first question is, as he says here, JSON field, oh, these are true and false questions, sorry, excuse me. So the first question, is this true or false? JSON field equals raw, source IP, address as source IP. Does this extract the source IP and all subsequent values as appearing in the incoming log messages? So this is going to be true. It's going to look for that source IP and it's going to extract it as IP. And it's going to call it source IP. Second one, double curly brackets enclosing a variable label are used to create parameters, true or false? And this was true when we saw this earlier up here. And Richard, who wants to ruin the fun and just say true for all, which is correct for this last one here. True or false, I use the setting icon in the message tab to change the color of the bar graph. Yep, you do. Actually, no, excuse me, I take that back. That's false. It's false. Like I was getting ahead of myself. Richard threw me off. So the question here is, is this true? I use the setting icon to change the color of the bar graph. No, it's actually in the aggregates tab. So here is the messages tab. Here's the aggregates, and that was a little joke between me and Richard. But yeah, it was false. All right, so cool. Let's keep going here. So lab 2. So lab 2 is geolocation. Saw this earlier with the map. Let's go make a map, and so that's what we're going to do here. The first portion of this lab is going to be repetitive. In a good way, because once again, we're going to need to specify our data. Now, I didn't read this whole thing. I guess I should encourage you to do, but essentially, as already discussed, geolocation allows us to know where users or systems are logging in from, might be quite helpful in security manners or manners. So what we want to do here is we want to create a query of our CloudTrail data that shows multiple IP addresses. So what we're going to do is, once again, first grab our CloudTrail data. Then we're going to go ahead and create all those fields again, like we had done previously. And somebody's going to grab all this information in step 2, create a new log search. And I'm just going to run it. Last time, remember, I went through each field and showed you how it was created. Well, I think you kind of get that already. If you don't, please let me know. Happy to go through it again. But once again, we're just looking for that field in the CloudTrail data and giving it a name that we prefer. Now what we're going to do is 2 things. Well, yeah, more than 2, but we're going to grab these 2 lines. Actually, so we're going to grab these 2 lines, do a Shift Enter, and then we're going to grab those next 2 lines. Now, why are we doing this? What we're doing in the first 2 lines is we're using where is empty. And so basically what we're saying with the exclamation point acts as a not. So we're saying, show us all the places where the actor is not empty. Basically, if the actor is not in the data, which could occur, there's some data that might not have an actor, we don't want to know about it. I only want to know about things that can be attributed to people in this case. Same thing with the event type. If the event type is blank, it's just not relevant for this use case. And then what I'm doing with the bottom two lines is I'm using these curly brackets again to create the parameters. And once again, I need to go into each parameter and add a wildcard so we get results. So what I should have done in these last few steps is, well, cut and paste a lot, but put in the looking for, basically only looking for places where data is, creating the parameter, and then putting the wildcard in that parameter to pull back data. So we have our filters working at this point. And so that's what this whole first chunk is. Now the next chunk, or really the next line, is what's important to us here. So I'm going to grab this line here, this lookup. I'm going to paste it in, but before I run it, I'm going to talk about it as I've been doing. So what we're doing here is we're utilizing a lookup table. Earlier, we used the lookup table for the event types. Well, we're using a different type of lookup table, the same theory of lookup tables, but different. Now, how is this lookup table different? Well, this lookup table is utilizing outside data. I mentioned earlier that there is CrowdStrike outside data, which is that threat detection data, but we're not going to talk about that right now. What we're going to be talking about right now is the geographic data, the mapping data that's available to you. This data is not by CrowdStrike, it's by a company called Neustar. And Neustar, that's what they do. They see where people log in from and attribute it to a physical location, and correspondingly, you get ads and sports scores from that that technology and weather. And so that's what we're utilizing here. So the system is utilizing IP addresses and looking these up in Neustar's data, although we house the data, but it's Neustar's data to determine where somebody is physically in the world. So how does that work? How does the code tell the system to do that? Well, here's the code that does it. And for this line, I want you to read it from right to left. What we're doing here is we have our source IP address. Remember, we have our IP addresses here. And in this case, we've renamed the IP addresses to be called src_IP, just because that's the name we like to use. Now, from going right to left, we're going to take the source IP. So we're going to take this value, and we're going to compare it to all the IPs that exist within the geolocation lookup table, which is that Neustar data. So we're going to look through all their IPs and see, do they match our IPs, essentially. If there's a match, we're going to ask the system to retrieve this geographic information: latitude, longitude, country name, city, region. There's more geographic data that can be retrieved, but that's all we need for right now. So we can actually pull a postal code and city and state, but we don't need that granularity. But what we get when we run this, and this only works for public IP addresses, is we now get geographic information. So here we start to see that Siraj is located in the UK. Kevin is in Riverside. Kevin is doing some work in Poland, etc. Now, once again, this does not necessarily mean they're specifically there because of VPNs, but that this is what the data is starting to show you. And so now what we can do is start to turn this data into a map, because right now I just have a long list of different people and where they've accessed the system from. But that map is probably going to be a little bit more helpful for me, or not, depends on your personality, but maps are good. So what I'm going to do is I'm going to go back into my lab, and I'm going to add this last line here. We actually don't need, we're going to add the last line. We don't need everything that's on it. It's a bit more verbose than we need, but it's perfectly fine. But what we're doing with this last line is we're saying, okay, take all that data and count it up, aggregate it, do math on it. When I do the math, I get the aggregates tab, and now I get, here Siraj did this, here Kevin did this from Russia, Kevin did this from Poland. But what I want to do, and the big seller of this lab, is that map. Very simply, I showed you earlier the bar graph and the pie chart. Now, since we're using latitude and longitudes, have this map icon enabled. And by clicking on it, now we have our map. And now, once again, is somebody coming from China? Is that good or bad? Well, I don't know. But certainly the system is now telling us about it, and we can start to make those educated decisions. All right, let's see. So let's see, that takes us through lab step 7. And so now what we're going to do, like we did previously, is we're going to go ahead and add the panel to our dashboard. So we're going to go ahead and click on Add to Dashboard. We're going to give the panel a name. And then we're going to reference the dashboard that we used earlier. And mine is, what did I call it? GB234. The colors are a scale. Let me show you. I can show you that in a second. Let me just finish this step real fast. And so when we get this, we're just going to click Add to Panel. What this is letting us know is that we already have a filter in place, which is good. We actually want to use that filter. So we just want to add a panel. Because what we can start to do here is now we have our 2 panels, and now we can start to filter on just what, let's say, Kevin is doing. Cool. Now, let me go, yes, that's that. Let me show you the colors. Actually, let me show you this. So it's actually based on an equation. It's not fully. Let's see. Oh, there we go. Oh, no, map. So it's actually based on percentage. Sorry, I was trying to find it. Let me see if John's going to take a look in the help to find what it means. So basically, the colors just red is the largest. John will find the help article. I can't remember the exact color coordinations. All right, let's see. Yep, then we have it in our panel. Once again, have a quiz, so we'll go through these quizzes. And these are true, false once again. First one, lookup uses CrowdStrike data to provide latitude and longitude. That's going to be false. It's a little bit of a trick question. It's the new star data that's the latitude and longitude. CrowdStrike is the threat intelligence. Yeah, new star, the way Richard spelled it, Neustar. Not the way you might think it is. And we also use Mapbox data for the maps. So NewStar is used for the geographic information. Mapbox is used for the drawing of the maps and going down the street level. Question number 2, I can display a map without aggregating data. That's false. So you cannot do so. You also cannot do a map unless you have latitude and longitude. So those are going to be required fields to create a map. And quiz 3, I can use add panel to add to an existing dashboard. It's really add to dashboard here. So I don't really add panel, but yeah, so that's false. All right, on to lab, let's see. Yeah, let's do lab 3. We'll probably take a break here. Probably after this lab, maybe the next one. Okay, so lab 3 is looking at top 10 number of failed logins. So once again, might be obvious why you'd want to do so, but certainly looking for failed logins might be helpful. Now, once again, does a failed login mean a user is trying to maliciously hack into the system? Or does it mean somebody forgot their password after a long weekend? Well, both could be possible. And so we can show you, what's occurring, and then you can decide what to do with that data. So we're going to go through this query. The first chunk of the query, once again, is going to be the same. We're going to take the CloudTrail data, we're going to slice it and start to use the fields with the JSON, the parsing of the fields again. So I'm really just going to grab all this. do a new log search, paste it in. I'm just going to run it just to make sure it runs properly. It should. Cool. So it's running. Now I'm going to go ahead and once again grab the items in step 5. So creating the parameters. So now I should have those event types and those actor fields. And now I need to put those wildcards in so I get results back. Now I'm going to go ahead and grab everything in step 7. And like I've been doing, I'll just talk about those again. So I'm going to paste them in and then talk about these lines. So these first 2 lines are those is empty again. So these 2 are saying once again, only show us where data is. Now in this one, we're saying show us where result is failure. Why do we want to see result failure? Don't we normally want to see successes? Yay, success, fail, bad. Well, in this case, we want to see failures because we want to see where people failed to log in, not where they logged in successfully. If somebody got successfully logged in, I don't care about that, although that could be a separate concern. But in this case, if they failed to log in, that's concerning to me. So that's why I'm saying here, look for where failure, result equals failure. And then I'm also specifying where event type equals AWS console sign-in. Now, this is is redundant because I have my type here and I just specify right there AWS console. But we're showing you just once again, kind of different ways to approach the same issue. And so in this case, I'm hard coding into my query. I'm using kind of air quotes for hard coding, but I'm going to go ahead and put those in. So let me go ahead and run this just to make sure I have everything typed in properly. Let's see, and let me just get some more data in here. Okay, and so if you're not getting any data, go ahead and create a larger time range. In fact, going through the lab probably a touch too fast. We actually should be using the last 24 hours. So I, like some of you, we're doing the last 15 minutes, which usually gets us enough data. But in this case, we want to go to the last 60 minutes. Should be enough. If you want to go all the way to the last 24 hours, you can. Just that's probably more than I need. So last 60 minutes at least gives us some data. All right. So I got my data. I am through lab, step 7. So I have my data right now, sorry, showing me all these different failed logins. So over the past 60 minutes, in fact, I'm going to use last 24 hours like the instructions tell me. So what I'm seeing is over the last 24 hours, there have been 77 results. 77 times over the last 24 hours, somebody could not log in. Now that's maybe good to know, but now I want to, once again, aggregate my data, and I want to use time slice in this next portion of the query. What time slice is going to do, so I'm going to grab these next 3 lines. I'm going to go line by line again. I'm just going to paste those in and let me do that. Okay, so I have my data loaded. Might take a few moments, 24 hours. It's going. It's not taking too long. Now I want to introduce the time slice. What time slice is going to allow me to do is look at my data, not granularly, more grouped together based on time. These 77 logins occurred over the last 24 hours. Did they occur during one specific hour time period, 11 a.m. to noon? Did they occur throughout the day? Did they occur throughout the day and the night? I don't know. And that might be helpful to me to get some understanding of that. And so that's what I'm doing with this line is I'm starting to introduce my time slice. I'm saying group my data in buckets of 1 hour. So 1 hour buckets or groupings. Now what I'm going to do is like we've done previously, I'm going to aggregate my data. I'm going to take my data and I'm going to count it by the time slice, by those 1 hour buckets, by the actor, by the event type, et cetera, et cetera. When I run this now, what I should get is an aggregates tab, my time slices, so my 1 hour buckets, and what occurred during that 1 hour, that bucket time. So for example, in the first line here, from 10 to 11 a.m., Ankit logged in or failed to log in once. Kevin failed to log in once between 12 and 1. Between 8 and 9 p.m., Goja failed to log in twice, and so on and so forth. Now, what I'm going to do with this very last line is I'm going to say, show me the top 10 actors, the top 10 users by time. So what users most frequently were not able to successfully log in during a 1 hour time period. So when I click enter, I should, let me take a moment here. Looks like it's still processing, but it's kind of finishing up. Yeah, it does take some time. that's 24 hours, so it's a long time. But what should occur once it's done is it should take your list, chop it down to 10, and keep only those top 10 users. And so that we can start to see during this time period, Kevin unsuccessfully logged in a few times. Now, if it was twice during a 1 hour period, once again, maybe he just forgot his, maybe fat fingered his password. Maybe he just forgot his password. That's probably the best excuse. Maybe the caps locks on, but many excuses or what might have happened. Now, once again, if you take this data and go to Kevin's manager and say, hey, I see Kevin's having a problem logging in. And the manager goes, yeah, he changed his password recently, and it used to be this, and now he keeps forgetting. Well, then this makes perfect sense. If Kevin's no longer employed here, then this becomes more curious. If Kevin is an automated process, then this becomes more curious, and so on and so forth. And so that's what this is able to show us. All right, let's see. Yeah, now what we're going to do once again, as we've done before, we're going to add the panel to the dashboard. So we're going to go to our aggregated information. We can, if you want, feel free to put it in a different format. Once again, we're just kind of playing around, but this table view is probably the most appropriate. Add the dashboard, do the searches. Excuse me, I give the panel name, and then go to SOC JB234. Click add. And now I should add panel again. Sorry, getting a little ahead of myself. And then now we have the 3 panels. Cool. All right, let's see, a little quiz here. First one, adding a wildcard in the parameter window means it will filter out everything. That's going to be false. It's actually going to include everything. As a wildcard usually means, I guess in various systems, but for us it means to include everything. Time slice groups my incoming logs into chunks of time. That's true. And then the following code, where is empty actor, filters out logs that do not have an actor. That's filters out. Yeah, that's true. So it's only going to include those logs that do have an actor. And so this not symbol is used in other places as well. I think we might use it one more time today. All right, let me just go back to our little schedule. I think we're doing okay on time. And let's do one more lab, one more now, one less later. So we'll do lab 4, and then we'll take a probably 10-minute break. If you need to take a break before, feel free to, of course. But yeah, let's knock this one out real fast. Not real fast, not to diminish its importance, but so what we're going to look at here is, as it says, account compromise detection from a brute force attack. And so what we want to look at is brute force attempts. Now, our data here is not great, as you'll see when we actually get to the final kind of reveal of the data. It's not as telling as it could be, but just use a little imagination. So what brute force attacks are is when somebody maliciously attempts to access an account using multiple passwords. So, okay, I know the account is J Brothheim. Let me try password 1234, 12345, 12346, 123, and so on and so forth. And what that the way it exposes itself is a lot of unsuccessful logins with possibly a successful login, where the successful login would be a success in your brute force attack. So what we want to do in this lab is we want to start to look at logins, unsuccessful versus successful. And the data could tell us something revealing. Once again, it won't be as revealing as it could be, but it still will tell the picture. So with lab 4, the first chunk of it is the same. So once again, we're going to grab our source category and the fields. So I'm doing a new log metric. I'm just going to run it just to make sure it runs properly, which it should. Cool. I'm going to go back and now grab the parameter fields. So I'm going to do a shift enter. And then I'm going to go ahead and put those wildcards in those parameter fields so that we return values. And I should get data. Cool. So hopefully we're all together. Now what we're going to do again is we're going to utilize the time slice, but we're going to use some other features as well. So I'm going to go ahead and copy, once again, as I've been doing, these lines in step 4, the lines in step 7, and then I'll talk through what they're doing because they're new, at least new for us today. So I'm going to paste in these lines, and then, like I said, once again, go line by line. All right, so we should once again have our query running. And now we are going to introduce the time slice. At this point, when we do time slice 1 hour, we can do other values. We could do 2 hours, 10 minutes, a variety of different options. The calculation of the time is established, but it's not utilized until we call for it further down. So I just wanted to kind of point that out. So at this point, like I said, if I was to run this, or if I run this right now with the time slice of 1 hour, the results don't change because we haven't told it to show the results with the time slice. Now, what I'm doing here is I'm using some Boolean logic, also some binary as well, to count successes. My goal here is I want to take all my log messages and I want to look for successful logins and I want to look for failed logins, and then figure out how many of each do I have. So how do I figure out how many successful logins I have? Well, I could go ahead and say count by success or count by result and show me successes. But what I want to do here is use the Boolean logic. What I'm doing in this line is I'm saying, go ahead and create a new field called success count. And you'll see that field in a second when I run this line. Look at the result. If the result equals the word success or the string success, tally a 1 in the success count column. If it does not equal success, tally a 0. So now when I click start, I'm going to have a new column called success count, and I'm going to have in this column either a 1 or a 0. If the result is a success, I'm going to have a 1. And I don't want to waste too much time just looking for a fail. Yeah, so, well, let's see. I also should be doing a larger time range as well. Yeah, let me do the last 24 hours here. Now, what I'm going to do in this next line here is kind of the same thing. I guess it's all actually the inverse, but essentially the same idea where I'm going to say, look at the result. If the result equals a failure, put a failure, the number 1, in the failure count column. So now I have a success count column and a failure count column. And I either have a 1 in the success count, or if I can find a failure, and then still going, I don't want to waste too much time looking for a failure. I would have a failure in account in a 1 here if the result is a failure. Now, what I want to do here is I want to now take these and start to count these failures and successes and group them together based on time and based on actor and based on event type. So what I'm doing here is I'm saying take the success count and add them up and group them by this portion. So when I run this, now I start to see at 9 o'clock, Goja logged in successfully 52 times and never failed to log in at all. So every time he tried to log in, he logged in successfully. Good, he knows his password. Kevin, actually, let me go back to the lab because there's still a little more. I was getting a little ahead of myself. So what we now start to see are the successes and the failures. What we want to do now is we want to go ahead and modify the results that we're getting, and we're going to add these 2 lines. Now, the first line we're going to add is showing us where failures are greater than 0. When I just showed you, or this one here, for example, Mike logged in successfully twice and failed to log in, that's not an example of a brute force attack. Now, I guess technically it is if on the brute force attack, the first password you tried worked, that would be an indication of it, but it's not really what we're looking for. So what I'm saying is if he logged in successfully every time, that's not what I want to see. So only show me where failures are greater than 0. When I run this where failures are greater than 0, I should now only have results showing me where failures are greater than 0. And now what I'm going to do here is I'm going to turn this into a failure percentage. So here, for example, I see Kevin logged in successfully 74 times and failed to log in 3 times. Is that good or bad? It's hard to say. I don't know. Here, Joe Schmo logged in successfully 11 times and failed to log in once. Is that better or worse? Well, I don't know. It's really hard to say. I'm trying to give some way of comparing apples to apples. So what I'm doing here is essentially creating, although it's not really the correct way to do it, but for today's conversation, I'm trying to create a failure percentage. And so what I see when I run this now is, and I'll go ahead and sort it, the failure rate, sorry, getting ahead of myself. Here, the failure rate was 40%. Logged in 7 times and 2 of those were failures. Conversely, here the failure rate was 1%. That's better. And so I can start to now dig into these ones that are more concerning. And if this is, and once again, this is where the data is not great. This is not a super example of a brute force attack. None of these really are great examples, if I'm being perfectly honest. Because really what you want to see is a lot of failures and no successes, or maybe 1. But once again, we have the data that we have. So, all right. Let's see. And then once again, now we're going to add this panel. So just to keep with the theme, add the dashboard, panel title. Dashboard is once again, well, by now I'm sure you know it. JV 234, and click add. All right, cool. So now we have our 4 panels. So we've now made it through lab 4. Oh, let's do the quiz. Oh, we still got the quiz. So the quiz. So true or false. The first one, the _raw refers to the raw data in the incoming logs in this example. JSON field equals raw event type as event type. So true or false? I believe that's true. Second one, if the result matches failure count, then return a 1 to failure in this example. Is this true or false? If result equals failure. So if the result matches failure count, then return a 1 to failure. This would be true. And then when you use time slice in 1 hour, you're grouping the incoming logs into 1-hour groups for the purpose of analysis. That's true as well. Cool. All right, let's go ahead and let's take a 10-minute break. So I'm going to put on a 10-minute timer here. And let's go ahead, get a little snack, get a little beverage, and come back in 10 minutes. And sorry, advertising and everything. We'll go ahead and then come back around. So let me go ahead and just get the countdown going. Oh, so many ads. So 10 minutes once the actual counter starts. There we go. So like I said, let's go ahead, take a little break. I'm going to step away. John will be here as well. Any questions about what we're covering or not, go ahead. So in the chat, we'll come back, pick it up, do a few more labs, take the exam, and call it a day. So see you all in a few moments. Thank you. All right, welcome back, everybody. Hopefully you had a good little break, but we're going to go ahead and continue. So when we left, we were finishing up Lab 4, and so now we're going to do Lab 5. Right, so once again, let's just pick up. So with Lab 5, what we're going to be doing is we're going to be utilizing the query that we looked at earlier. Well, actually, we didn't look at this earlier, excuse me, but we looked at it in the security demo of detecting a land speed violation. So what we want to do here is we want to determine a land speed violation. And what a land speed violation is when a user logs in from one location, logs in from a different location, and it's too short of a time to be practical or possible. So for example, let's say you log in from the United States and 3 hours later you log in from Egypt. Well, that's not technically possible. It's kind of getting closer every day with space travel or whatever, but it's not possible to do. And so that is a land speed violation. When I worked at Google, we used to call this the Superman problem, where unless you were Superman, you could not log in from one location to another within a realistic time period. Now, VPNs kind of take this and throw it all into chaos, because if you're coming from one location and a VPN and another, then that is possible. But we're going to assume that you're not using VPNs here. So what we're going to do is we're going to look at this query, and it's going to be quite a query that's going to allow us to, or allow the system to look at somebody logging in again, and the system is going to determine is that normal or not? Is that possible or not? And so let's go ahead and take a look at this query that allows us to determine this. Now, this query is a bit much. It's quite a query, as you're about to see. It's not important that you understand every single line of the query, but I do want you to, at least at a higher level understand, because here's the query flow chart that we're about to go through. So let's look at this at a high level, and then let's look at this through the code, through the query language. But essentially what we're going to do is select a source category. We're going to parse out users and IP addresses. We're going to get rid of null IP addresses because we only want to look for IP addresses that are valid. We're going to have the system create the start of when a user logs in, and then determine how many times that user's logged in from the IP address. We want to filter out single logins. If somebody logs in once, that's fine. I don't care about that. I'm interested if they log in once and then log in again from a different location. That's not possible to get to. We're going to get kind of into the weeds. We're going to convert some of the IPs into a decimal format and then actually format them back. This is where it gets a little, don't really worry why we're doing it, or just we'll kind of get through that step and just continue. Then what we're going to do is we're going to take that IP address and we're going to geo lookup it. We need to see where that IP corresponds to someplace in the world. Now, once we do that, we need to calculate the distance between the two logins. Now, how do you calculate distance on a sphere? It's not a straight line, there's all those things. And so we'll talk about that in a moment, but this Haberstein formula allows us to figure out locations, distances in a spherical world, excuse me. Then we're going to calculate the speed that a user would have had to travel to do in that distance. So if somebody did log in from the US and Egypt in 3 hours, how fast would they have had to travel to do so? We're going to filter out logins from the same IP address. And then what we're going to do is specify the impossible speed, where we're going to say, unless basically they can't travel over about 500 kilometers an hour, because like I said, we just don't have really the technology for that. So if they're traveling over 500 kilometers per an hour, then that's questionable, that's suspicious, and we want to have that reported to us and once again formatted for presentation. So let's go ahead and grab the query. Once again, like I said, this query gets a little weird. It does get kind of mathy, but we'll get through it together. So the first portion here is the data. So as we've done multiple times, we're going to grab our CloudTrail data. I can grab all 3 lines here. Doesn't really matter. Actually, we do need to log back in. So John, if you can go ahead and paste the credentials back in case anybody else got kicked out. If you didn't, great. But if you did, let me go ahead and just log back in. Sorry about that. All right, there we go. So I'm logged back in, doing new log search, pasting in the query, just going to run it just to make sure I get my CloudTrail data, do last 24 hours to get a lot of data. And cool. Okay. Now we're going to go back to the query. Now in this portion of the query, we're going to go ahead and, well, tells us what we're going to do. We're going to filter out valid IP addresses, and we're going to create essentially a starting point. So when the person logs in from that public IP address, start a clock, and then find out when they log in again and kind of end that clock. And so that's what this is doing. We're looking for the oh, yeah, let's go through it. So we're looking where the user matches an actor. So once again, we're going to use these actors again, these users, these parameters. We're going to check to make sure the IP is a public IP. That's what is public IP is doing. And then here is where we're starting to create a clock, if you will. So we're starting to say the message time is the login time by user IP. So that's that first login, and then sort these users and login times. So when I run this, it's just going to really filter out a lot of stuff. And now it's going to start to give us our users, what IPs they logged in from, and what time they logged in from using I want to say epoch time. I think that's what that is. I'm pretty sure. Yeah. So now we should have exactly like I just showed you. Now what we want to do, once again, getting in the weeds, but now what we want to do is we want to take our IP address and we need to convert it into a number. This is where, like I said, just kind of gets mathematical, or not mathematical, just more formatting. And so what we're doing here is we're taking our IP and we're converting it to an IP decimal. And then we're back shifting. So we're essentially associating that IP decimal with the user. And we're also looking at a login time and starting to do a previous login time. So essentially, let's run it because I think it will be a little bit easier to see. What we're now starting to see is Siraj logged in from this IP at this time, and he logged in previously at this time. And so we're now starting to get our times, starting to get our locations with our IPs. We're going to get further with that location, but that's what we're starting to do. Now what we're going to do here is we're going to take our IPs and turn them back, taking the IP addresses from the decimal format and putting them back into the octet format. So basically turning them back into IPs. And so now I should have a new field called previous IP. It's actually going to show all these octet fields. I don't need them. I don't know. But here we see the IP. So we have our current IP and what time that person logged in from it. We have the previous login and where they logged in from. So now we're starting to see login here from this place at this time, this place at this time. Now we want to do our geolocation. We want to figure out where is each location, because they could both be in California and, that could be somebody went, just drove across the street, but we need to start to have the system determine that. So what we're doing is we're starting to look at the IPs as well as the previous IPs and associate a location with them. Starting to get busy or full screen, but now what we're starting to see is, let's see if I can show it. So here on the second line here for let's see, it's not. Oh, there we go. So on the second line, for example, we see Siraj logs in from Brazil and the United States in a 24-hour period. Now, once again, that's perfectly possible. Could log in from New York, take a flight to Rio de Janeiro within 24 hours, do work, perfectly acceptable. But we want to take once again, this further and have the system start to determine how far apart they are, how fast would Siraj have had to travel to do that? Is it possible? And so that's where this Haversine formula comes in. What it's doing is it's looking at the latitudes, looking at the longitudes, looking at a sphere, and figuring out in a spherical world how far those far apart those two locations are in distance in kilometers. Haversine uses kilometers, so we're going to use kilometers as the majority of the world does, but we could convert this into miles if we wanted to, but I don't really want to. So now what we start to see here is our distance. Now we want to calculate the speed user would have had to travel in order for this to occur. So, and we want to see only where the speed is greater than 0. So what we're doing is we're taking our login times, dividing by 336 million, whatever, to get hours. So basically taking seconds and turning them into hours. And then getting hours per mile, hours per kilometer, or kilometer per hour. Sorry. And so what we should get and if I go far right here, now in order for this to have happened, so here we had somebody log in from Mexico and log into from Brazil within 600th of a second. Now, if they did that, they would have had to travel 124,000 kilometers per hour, which is not possible. And so now this is where this is curious. Let's see. I'm just going to sort the apparent velocity. So here, for example, so here we have Germany. So if somebody logged in from 2 locations in Germany, and they would have had to travel 139 kilometers per an hour to get between each location. Now, that's fast, but that's possible. And so that's what the system can start to tell us. Now, we want to take this just a step further here. What we're doing here is we're starting to define our suspicious speed, where we're saying anything over 500 kilometers per hour is not possible. But 136 kilometers per hour is. So it might be curious, but it's not really that fishy or that that fishy. But this is, if they're going above 500, it's more curious. And so now we're starting to see, here's the apparent speed, here's the suspicious speed, and these are all people or actions that are faster than that. All right, let's see. And then what we're going to do here, really just as it says, formatting. So what we're doing here with the formatting is, well, as formatting does, cleans it up. We're using concatenate. So we're taking the IP addresses and we're combining them to format them. We're renaming. So if the country names equal, put them together as countries. Only show us these speeds, sort them, etc. And so ultimately what we get, there we go. And this is also a case where we don't really have, it would be probably more exciting to have a better, more telling data. But what we have here are many examples of where somebody Kevin logged in from France and Australia. The distance is that far. The login time difference was milliseconds. That's what this is showing. And he would have had to travel 59 trillion kilometers an hour. That's not possible. And so once again, that's weird. All right, so like I said, I know that a lab is a lot just to take in, but hopefully, conceptually, I hope you understood where we're coming from, the ability to use some of the mins, some of the is publics, the nulls to include or exclude our results, setting values here. This one's kind of helpful. So yeah. And then there should be a quiz. Oh, then we need to add the panel again. That's repetition. So add to dashboard. I'm just going to call this speed because I forgot the true name of it. sock underscore JB234. This is normally much faster. I think it's just my machine at this point. And then click add. And once again, panel here. And finally, there we go. Cool. So now we have our panels. So let's go back to lab 5, the quiz. Might as well run through this as we've done before. So the geo lookup receives an IP address and returns a location. That's basically true. The Haversine formula was used to convert the octets to decimals. So that's not true. That was the Haversine formula was used to determine the coordinates on a spherical globe. If you don't do anything with a spherical globe, you'll probably never use the Haversine formula again. And this is not something you use every day. This is really a one-off. It's just kind of demos kind of well, but it's not something I expect to use in everyday use. And then lab speed violations allow you to detect suspicious user activity. True. Once again, could be justifiable activity, but it certainly would be deemed as suspicious. All right, let's continue on. Lab 6. So lab 6 is going to introduce, well, not introduce, we already used these lookup tables. So we started to look at lookup tables earlier. We've looked at 2 different examples of lookup tables so far. Actually, technically 3. We've looked at, the first one we did was in the first lab, we used that shared/events types as a lookup table. We used the lookup table of the geographic data. And we used the lookups table a little bit, we haven't really gotten into it yet, of the CrowdStrike data. Now, what we want to show here is how to create your own lookup table. And so, what just happened? There we go, back to lab 6. And so what we're going to do is create a lookup table. And so as we've been doing, grab the steps, copy them, and run them. So I'm going to do another new log search. I'm going to paste the query in, and I'm going to turn off each line so that I can go line by line. So in the first line, what we're going to do is we're going to look at CloudTrail data as we've been doing many times today. Now, what we're going to do here next is we're going to go ahead and pull out that field of username. Remember, we're using that field of earlier of the actor, of the user. So I'm going to run this. I'm also going to put this for the last 24 hours. So I'm going to read these 2 lines, and what I should now get are users or actors. Now what I'm going to do is count by the actors. How many actors do I have? How many users do I have over the last 24 hours? So I have 14 users. Once again, well, it's a user, whether it's not a physical person or a machine account, that's indistinguishable from this standpoint, but we're considering this a user as well. Now, what I'm going to do here is I want to get this list of users, and I want to use this list of users in my queries, in my parameter search. So what I'm going to do with this 3rd line, or I guess it's technically the 4th line, is I'm going to remove a field. That's what I'm doing here is I'm doing fields minus removes a field. I'm going to remove the count field. The reason I'm going to remove the count field is I don't care how many times a user showed up. I care that Kevin and Mike are users. I don't care that Kevin showed up 15,000 times. If he showed up 1 time or 1,000 times or 15,000 times, he's still a user. And so the count itself doesn't matter to me. And so I'm just going to remove it. That's, like I said, what this minus does. So when I run this line, the count disappears. And now what I want to do is save this list of users. And so what I'm going to do is save it. I can save it to a shared location or a kind of a private location, but I want to save it to a shared location. But it doesn't really matter. Might as well do shared just since that's what the lab tells us to. And I'm going to go ahead and put my initials and my number. So I'm going to do shared JB234 JB234 underscore AWS underscore actor underscore list. So I should have this in here modified for your needs. I'm going to go ahead and copy this line just so I remember it. And then I'm going to click search or start. When I do, it's now going to run this query, and now it's going to ask me if I want to run this query. By doing so, as it says here, the data may be saved. That's fine, good for the warning, but I'm going to click run. Now what should happen is this data should now be saved to a lookup table. Now, let me prove it, because you're probably going to say, no, Josh, you're a liar. What I'm going to do is do a cat command. So what I can do is I can go to a new log search. I can do cat space that location. And when I click enter, I should get that list of users. If you do cat shared JB234, etc., paste it in, you should be able to pull up that list as well because it's shared. And so now you or I or anybody in your organization can start to reference this list. And that's what we're going to do in a moment, is actually use this list. But now we have a shared lookup table. So let's go ahead and kind of finish up the lab. Now what we want to do is we want to manage our parameters to utilize the lookup, because I have a lookup table, but nobody knows that. So what I'm going to do here is, as it says in the SOC dashboard, so I'm going to go to my dashboard. I'm going to go to one of the queries, and I'm going to click show and search. It really doesn't matter which one I use. Now what I'm going to do is I'm going to go to the parameters and the parameter for the actor. So I'm going to go to actor. I'm going to click on the three dots. I'm going to go to manage parameter settings. And now I'm going to fill in the blanks essentially. Most of this I can leave as the parameter name, the default value. What I want to do here is go to set value for parameters. I want to utilize a lookup table. And I want to specify where that lookup table is, which is going to be that shared location. I need to put the field here. Field actually should be imported automatically. So it should actually pull the field from the lookup table of actor. And then I want to click save. Once it's done saving, now if I go to the actor field and remove what's in there, I now have a pull down of all my values that exist in that lookup table. And keep in mind, this list it's not dynamically updated. It can be, but this list is going to be dynamically extracted. So every time you go here, it's going to look at that shared JB234 AWS actor list to see if it has been updated. So you can periodically have this location updated, and then as a result, each time you go to the actor, that would show the updated information. All right, cool. So quiz, true, false, once again. To display a lookup table, I use the command CP. That's incorrect, it's the cat command, CAT. Search parameters allow me to pivot quickly to any metadata values. I'm going to say false only because any, that's just, I don't know, I feel like that's kind of a leading word. So, but it does allow you to get to some of your values. And then I use the save operator to create a lookup table. And so that is correct. So that's, remember we use that save. All right, cool, let's keep going. Lab 7, I don't know that I'm going to go over it. I'll talk through it. I think just in the essence of time, I'm going to skip it, but let's just discuss it, what it does, because it's still valuable. What Lab 7 is, as I mentioned earlier, exporting your dashboard out. So you've just created this dashboard somewhere in here. And you can utilize this in your environment. If you're using CloudTrail data or you have CloudTrail data in your environment, you can export this dashboard out, import it into your production environment or whatever environment, possibly need to modify the source categories, modify where that data is stored, but the rest of the query will run, and that's what we want to encourage you to do. And so that's what this lab is going through. Once again, like I said, I think I'm going to kind of skip it just in the essence of time. And so what we would have you do is export the dashboard. The dashboard is going to be exported in JSON, which is kind of cool and kind of new for us. So you do get the complete JSON format, which you can actually utilize to edit the dashboards. So I showed you earlier how you could change the color. Well, going through the JSON, you can change the font size and everything. So you can get quite granular. We don't do that in this lab. Yeah, we just don't, but you can. And so that's what this lab is showing. Taking the JSON, bringing it into some sort of text editor, modifying the source category. We don't want it to point to source category labs AWS CloudTrail. You would want to point it to company / CloudTrail or whatever it might be. Adding the lookup table. So basically recreating the lookup tables in your real environment and then importing it all back in. So like I said, yeah, I don't think I'm going to go through it, but it is a great feature, good way to share dashboards. You can share them, of course, through the sharing mechanisms in Sumo as well. But this is another way to share is through JSON. So the quiz, I guess we'll go over these. We didn't really do the lab, but you can export the output to a JSON format, so that's automatic. And so we see an example of that right here. Before importing, I must change the pointers to my data using a visual text editor. Well, I guess technically you could, it doesn't have to be a visual text editor, but you do, because otherwise the pointers are pointing to the lab data versus your data. And then after importing, I cannot share the dashboard with others. That's incorrect. So the last step we have in this lab is sharing that newly imported dashboard that is now in your production environment with your peers who might benefit from it. All right, so let's do lab 8. Lab 8's, I mean, they're all important, but lab 8's a good one to wrap up with, because now we're going to use the threat intelligence data, the CrowdStrike data that I've alluded to a few times. So as it says here, lab 8, using threat intel wisely to avoid costly data breaches. Basically, what we can use is CrowdStrike data to detect or look at indicators of compromise, or as we call them, IOCs. So let's do it. Let's just get into it here and start taking a look at this. Now, we do have you looking at, I don't know, I still don't like I would bring you through this whole first portion, but what we're having you do here is looking at what we call scheduled view. Scheduled view is a helpful feature for some of you, well, I guess helpful for everybody, but what it does is it allows the system to take a query and run it in the background in perpetuity every minute and bring those results back. Run the query again next minute and bring those results back. And so by doing so, you can run basically you can run a query where you ask for those results rather than running the query from scratch. And so it should reduce the amount of time. As you saw, some queries can take a while to run. And so with this one, since it's running in the background in every minute forever, it's going to bring those most recent results back to you. So it's not real time, but it's delayed by about 30 seconds or a minute, which in this case is more than sufficient. So what we're going to do here is look at that scheduled view, which I think you'll be able to do. You should have access. We're going to go to manage data. So we have the steps here. We're going to go to manage data. We're going to go to logs. We're going to select scheduled views. And then there should be a scheduled view called IP threat. And then I'm just going to click on it. And what I'm seeing here is the query that is used in this query. The query I was using, the query that is comprised is making up the scheduled view. So here is this query. And so we're going to start to utilize this query in a moment because it's going to utilize our lookup table. What we're going to do here is I'm going to go ahead and copy the code. So I'm just going to copy this whole thing. I'll also paste it into the chat in case you're having trouble getting into this section for whatever reason. But what I want to do is I want to do a new log search, and I want to paste in the code. Now, in this case, the code is separated, not in every case we've done, the code has been separated by pipes on separate lines. In this case, the way I paste in is it's all on one, not one big line, many lines, but there's still the separation of the pipe. So this is going to run, then this is going to run, then this is going to run. It's just not visually pleasing. So I apologize for that, but the query itself is still valid. So what's this query doing? Well, let's talk through it. First, the query is, and I should, let me just see something real fast. Yeah, I'm going to steal this portion right here. In step 8, I'm going to grab this query because this really has everything I need in the separate lines, and it's going to make it easier to demonstrate. So let me just do that again. Let me do new log search. Let me paste it in. That's better. And now let me comment off some of these lines as we go through them. So yeah, this will work better. Okay. So what are we doing in this query? Well, at the very front of the query, we were looking at all the data. We're not looking at CloudTrail data. We're not looking just at labs data. We're looking at everything, which is what the wildcards notes. From that data, we're going to search. And what we're going to do here is we're going to utilize regex, regular expressions. This is another way to parse, many other ways to parse. We have a class on search mastery that really goes through this better. Not better, just more in depth. But what we're doing is we're parsing. Basically, we're telling the system, look for an IP address. Look for something with a number, .number, .number, .number in it. When you find that IP address, call it an IP underscore address. So this is going to run. It's taking a little longer than it should. But basically, it's gone through this entire log message and found number, .number, 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 and called that an IP address. Here's another one. Actually, wait, where's the first IP? Here's the IP address, and so on and so forth. So now we start to see over the past, I'm just going to do 60 minutes. I don't want to do a full 24 hours. We start to see all these different IP addresses. Now, are these IP addresses good? Are they bad? We don't know. And this is where CrowdStrike is going to help us. What we're going to do on this next line is say, don't show us any IP addresses that have 0.0.0 or that have 127.0.0.1. We want to exclude those. Those are not public IP addresses. We can't look them up through CrowdStrike, so don't report them. Leave them out. Now, here's really where we get into the whole point of this thing. Here's our lookup. Now, if you remember the geographic lookup, it was similar, but a little bit different. And this one is similar, but different too. It starts the lookup. It has the various fields. And we want to read it from right to left. So what's this lookup table doing? What it's doing is it's taking the IP address that we just defined and comparing it to threats in the CrowdStrike database. Basically, in the CrowdStrike database, instead of calling it an IP address, it's called a threat. Now, from those threats or those results, I don't want to look up latitude and longitude. That's not relevant here. What I want to look up, though, is type, actor, threat level, etc. So now when I run this, for each IP address, now this is why we do want to actually continue with the filter, because we're seeing some results that don't have all the fields filled out, which is not really helpful. And so that's why I want to use these additional fields, additional lines. So what I want to do here is say, look at the IP address and show me only where there is a malicious confidence. Also, only show me places where there's an actor. I just want to filter these results, just clean them up a little bit. It's a little sluggish today. I think it's me though. But let's see, it should be popping up in another moment or two. And what it's going to show us is, there we go. Here it comes. Let's see, come on. But what it's going to show us, sorry, is the IP address and what essentially CrowdStrike thought of it. in a field that we're calling malicious confidence. Now, the field is originally called threat level, but what we're doing here is we want to rename it malicious confidence because I don't know if I need a reason or not. Maybe I do, but that's what I want to pull up. So what I start to see here is I want to just find some better real IP addresses. Yeah, well, even from the screen, we can go through this. So what this is seeing is it found this IP address, and this IP address, according to CrowdStrike, has a low malicious confidence, meaning it's not likely to be malicious. Now, is it perfectly safe? I don't I mean, a threat has to start somewhere. It could have been safe and then gets taken over and becomes bad. But, in this case, we're going to assume it's the original IP. And so in this case, this could be a safe IP. Now, comparatively, let's try that. Let's keep going here. I'll let it keep going. Conversely, if we had seen this as a high malicious confidence, then that might be more concerning. We might want to then blacklist that IP or block it or whitelist it and allow it to do things, like I said earlier. You need to decide what kind of actions to take with that. Let's see, so it's still going. Then what we wanted to do here, just to finish this off, and so here's an example of a better illustration in the image of what we were starting to see. But what we start to see is the IP address, the actor, in that the system is starting to determine what this is IP address associated with. So in this case, these IP addresses have a high malicious confidence, meaning they're probably bad, and they're associated with these kill chains and these actors of wizard spider, which is some scary virus. And so, that might be helpful for us to know. All right, let's see, did it finally run? I don't know. I need to see what's going on with this. All right, we can still finish up here. So the last part I do want to show, let me just see if this will, works real fast. It's kind of an important way to wrap things up. What I'm trying to show is the outlier feature. All right, there we go. So doing this query, it seems to have picked up some speed. There we go. Okay. So what I have here, what I've done is, sorry, I kind of jumped ahead a little bit, but basically what I have here is time slices grouped together by 1 minute. So basically a 1 minute bucket of time. And I have the IP address that's associated with that time, or that time, the malicious confidence, the actor, the kill chain, and then what source categories. So where is this IP address showing up? So here, this IP address is showing up in my Office 365 data. That might be concerning, versus showing up in our Apache data. But what we want to do here is we want to go ahead, and after we count all this, we want to use the fields. And we actually want to get rid of a whole bunch of these fields because they're not really relevant. What I want are just 3 or 4 fields. I want fields that show me, there we go. I want fields that show me how many IPs showed up as being concerning, having that malicious confidence of just really showing up. Actually, then in this case, we're not determining what the malicious confidence is. So what I have are all these IPs that have shown up. Now, am I concerned that 1 or 2 IPs or 10 IPs are showing up in a particular minute? Is that a lot of IPs to show up, or a little bit of IPs? And what I want the system to do is help me in determining what is normal and what isn't. And that's what's going to occur here. So what I have my field. It should be formatted a little bit differently. There we go. Okay. So now what I'm going to start to have are my time slices. There we go. Come on. All right, so I'm starting to get my groupings of time. So this is showing me how many IPs have shown up in each minute. And what, like I said, what I want to do is determine what is a normal amount and what is not. But I want the system to do it for me. And that's what's going to occur when I use the outlier feature. The outlier feature is going to look at all these values that have occurred previously and start to use a mathematical calculation based on standard deviation to determine, like I said, if these are normal or not. And so that's what we're doing here with this very last line, is we're saying take the counts, the amount of IPs that showed up in each minute, and count them and group them and do math against them. And that's what the portion I'm highlighting is. I'm just going to refer to it as math for right now. And so when I click start, the system is now going to look at the history, the previous periods in time. It's going to look at the values in those time periods and start to calculate what is normal, what isn't, using standard deviation. So it's starting, it's coming. All right. And so we're starting to get a feel for that. So I'm going to try and let it be patient here, but okay, I'm good enough. So for example, I'm just going to wait one more moment. All right, that's good enough, I think. So for example, at 5:13, there were 1,800 IP addresses found. Is that normal or not? You probably don't know. You need help in determining what's normal for this organization. Well, the system, based on the math, has determined the appropriate ranges between 2,300 or 2,378 and 1,587. 1,853 is within that range, and so that's considered acceptable or normal or good or whatever adjective you want to describe. The next period in time, there were 2,000. Now the range has changed a little bit. It's a little bit tighter. It's not 1,500 to 2,300. It's now almost 1,700 to 2,300. Actual is 2,000 within that range, so that's good, whatever. Let's take a step over here. Here, the system has now determined an acceptable range to be 1,652 to 2,264. The actual is 1,649. That's not within this range. And so here we see a count violation that's letting us know, hey, this is not acceptable. This is not within this range. Now, what I can do here is I can put this data in a line chart to illustrate it better. What this line chart is now going to show me is the light, I guess the darker blue line here, we can call it, is showing me the actual count of IPs during that 1 minute period in time. The cloud is showing me the higher and lower limits of what is expected based on the math. And then the pink triangles are showing me when I am outside that range. So what this is showing me is over the past 60 minutes, there have been 5 periods of times where I've had a different amount of IPs that are expected. And once again, is that a bad malicious attack? Well, maybe, maybe not, but it might be indicative of something. It might be letting us know that more IPs are showing up. Maybe we're getting more IPs, more unique viewers, more traffic. Maybe we need to stand up more servers. Many things we can kind of come and decide what to do with this information. But from a security standpoint, this is showing us those outliers, or from any standpoint, it's showing us those outliers, not just security. So wanted to finish up with outlier. It's a really important feature. I don't think this lab, at least the performance of this lab, didn't really do it justice, but hopefully you got a feel for it. And so with the quiz, well, just to finish some of this up, you can check all the incoming public IPs using CrowdStrike, and so that's true. And CrowdStrike is the data you can utilize. I'll also put in, I don't know if John might have done this already, so if he did, but just some more information about the threat intel stuff. Oh, you already did. Okay, well, shows you how important it is. We both thought it was worthwhile. When using the outlier command, the threshold equals 3, that sets the standard deviation. So we didn't look at that. I'm trying not to rush, but I think I am a little bit. But here's the outlier operator. And here is the portion that you can customize to configure that math that is utilized. And as the quiz, true false question asked, the threshold is really where you set that standard deviation. So by setting that value differently, it's going to impact your results. I'll show you just an example just kind of quickly. So here I have a standard deviation of 3, and it's showing me 5 outliers. If I change the threshold to a 2, I'm going to have a more narrow view of what is acceptable. And now instead of having 5 unique points, I am probably going to have 10 or so. Now it's going to take a few moments to load here as just life is happening. But you were starting to see more pink triangles. So my data hasn't changed, just what is considered normal or acceptable has. All right, and then finally, let's see, we're all over the place now. The quiz question 3, data doesn't count against ingestion when using pre-aggregated scheduled views. I believe that's true. Okay, let's yeah, pre-aggregated don't count against your data. That's good. All right, let's get into the exam portion. Certainly, if there's any questions, please ask. I know John's been helping you guys out. So, but of course, any questions, please do ask. But let's get you to the exam. So I'm going to go back to my slide deck just for a moment. Okay, for the assessment. So we're about to take an exam. The exam is free for you, free for your organization. So no cost for anybody. We want to get into the exam. So to take the exam, what we're going to do is first we want to log in, or you want to log in as yourself. We don't want training analyst 347 getting for the credit for exam. We want you as a named individual. So what you're going to want to do is make sure that you log out of the training account and log in with your corporate, your professional, your personal Sumo Logic account, which everybody should have. If you don't, let me know, but everybody should have their own account here. So go ahead and do that, or start to do that while I'm kind of going through this. The way to know that you're in the correct account is when you do log in or think you're logged in. If you go to the black bar on the bottom left, it should have training and it should have your name. So if it says training analyst 234, that's not the right account. If it says Bob or Bill or Jennifer, then that's the right account if your name is one of those. So make sure you're logged in as yourself. Then what you're going to want to do is actually, let me log in as myself to really show you where to go. And if you already know where to go, feel free to go and get started. But I just want to walk everyone through. All right, so once you log in successfully, as described, you should have your name. You're going to want to go, you should be brought to the home page automatically, but you'll want to make sure you are there. You're going to want to click on certification. Once you click on certification, you're going to want to click on get certified. And when you do, you should be brought to a new certification portal. If you're not, we can, well, I can help you with that, but ideally you should be brought to a screen that looks exactly like the one that's on my screen right now. And what you want to do from here is you want to choose get certified. When you select get certified, you'll see all the exams that we offer. Well, I'm not going to do all of them today, but today we are going to go ahead and utilize this one. No, excuse me, where is it? Yeah, it is this one, sorry. Cloud security monitoring analytics exam. So this one on the top row here, this red, maroon, I don't know what color that's supposed to be. So once you select the cloud security monitoring and analytics exam, you'll just register for free. It's going to give you some basic guidelines, and then you'll start to take the exam. Let's see, a couple other things real quick. So for the exam, I should have mentioned this. I don't think I did yet. So the exam is going to take consist of about 20 questions or so. You're going to have 60 minutes to take it. You're not going to need all that time. I think we'll still get you out at probably the top of the hour. Although that's really up to you. I don't want you to rush. You need a 70 to pass it, and it is an open resource exam. So like many of our other exams, feel free to use the Sumo Logic documentation. You have access to it when you're creating your queries in the real world, and if you're taking an exam, I think you should have it as well. So, feel free to use all the documentation available to you. For those logging in, looks like there's some issues. You may have be using SSO to log in, but we can't provide passwords. But what you can do if you don't know your login is you can request the password to be reset. So that's something you can do. Let me see, what else do I want to tell you about? So once you're done with the exam, feel free to log out. You don't need to, hang out till everybody else passes. But more importantly, and I'll leave this up. Still one more slide, but just as a reminder, we want you to take advantage of this. So, once you do pass that exam, and I'll show you how to get into that exam again for those of you that are still getting to there, we'll want you to, send the certificate to training-promotions to get your Uber Eats. So I'll show this slide later. So for right now, let's see. So if you're ready to start the exam, go right ahead. I'm going to once again just kind of talk and give a few more instructions, and then I will shut up. So, but let's just make sure everyone's in. So once again, when you log in, you're going to probably be on the home page. You're going to go ahead and click on certification, and then choose Get Certified. You should automatically be brought to this screen eventually. And from this screen, you're going to choose Get Certified. Once you're in the Get Certified, then you're going to select the exam that you want to take. And for today, we're doing the Cloud Security Monitoring and Analytics. As you see many other exams, and you're welcome to take those courses as well, but this is the one we're doing today. So resume. Well, you will have wouldn't have resume. And then you would start the assessment. One last thing, you're going to go through the exam, you're going to do all the questions, you're going to do great. When you click next, or when you click submit rather, it's going to give you your score. Excuse me, when you click next, it's going to give you your score. It's important at this point, when you get your score, and it's probably going to be better than mine, that you click submit. If you do not click submit on this screen, then you will not get credit for the exam. So it's just important that you do click submit. Once again, once you click submit, it would show you your certificate, and then you would go ahead and send that to the training-promotions. So go ahead and start the exam. I think we're pretty good on questions. I think John's helping just a couple people get in, but I think other than that, we're pretty good. So yeah, good luck on the exam. Hopefully you can join us for the rest of the week. So tomorrow we're going to be doing Cloud SIM fundamentals, and then the next day Cloud SIM admin, and those two courses, I guess name implied, go hand in hand together. So hopefully we get to see you for both days. So yeah, all right, let's go ahead. Like I said, I'll leave this up here. Any other questions, go ahead and just throw them in the chat. But once again, thank you for attending. And like I said, I'll put myself on mute so that you can concentrate on your exam, but best of luck, and we'll talk to you tomorrow. Cool. Thank you, everybody.